Alrighty, ladies and gentlemen, we are going to wrap up Chapter 2 with this last part of Lesson 2-6 and 2-7. We're going to see ratios and proportions and how that relates to percentages. So before we have solved for variables on both sides of the equation by undoing the order of operations with SADMET, right? So remember, undoing order of operations means I want to isolate the variable, and isolation kind of means they're sad, so that's why we call it SADMET. Alright, good way to remember that. So now what you're going to learn is actually how to solve for variables in fractions, right, by solving proportions with cross multiplication. So this is another technique that we can use to find that unknown value for a certain variable. So let's have a little quick review of actually first some vocabulary. We're going to talk about ratio, proportion, greatest common factor, and cross multiplication. So hopefully you are familiar with that and units. So let's have a quick review on equivalent ratios. Remember, equivalent means the same. Okay. So who has ever had to scale like the amount of like a recipe when you have like more or less people? So I remember once like on a box for pancakes it says like add this amount of cup of flour or this amount of eggs, this amount of like milk, but it's like 4 servings. And I'm like, I just want to be for myself. I want 2 servings. Right? So I cut down all of the amounts by half. That's called scaling, okay? So let's say I'm making some orange juice, okay? I'm making some nice OJ over here, and then I have 3 cups of concentrate for every 5 cups of water. So I can write this relationship as a ratio, and a ratio is the same thing as a fraction. It just shows a relationship. So 3 cups of concentrate, all right, for every 5 cups of water. So now I look at these different relationships right here, okay? Now let's ask, is 3 cups of concentrate for every 5 cups of water the same thing as 6 cups of concentrate for 10 cups of water? All right, these are different ratios, but are they actually the same value? Okay, so actually if you look closer, you can see that like the greatest common factor for 3 and 5 to multiply into 6 and 10 is actually times 2. Right? If you multiply the top by times 2, you'll get 6. If you multiply the bottom times 2, right, you'll get 10. And why is it that if I multiply the top and bottom by 2, you get the same value, right? 3/5, same as 6/10 in value. So let's do a quick review on multiplying fractions. And then multiply 2 over 2, right? It gives me 6/10. Remember that 2 over 2 is equal to 1. And anything that you multiply by 1 is just the same value, right? It's the same thing. So 3/5 and 6/10 is actually the same value. You just scale it bigger when you write it as 6/10. It's like zooming in to kind of see a bigger picture, right? Same dimension, but you're kind of scaling it bigger. So that's the same for the rest of these values, and let me show you what that looks like. Right? So to get 9/15, you multiply like when you have 9 cups of concentrate for every 15, right? You just multiply it times 3, right? So 3/5 equals 9/15, right? Same thing for 12/20, right? You multiply everything times top and bottom by times 4. 15/25 multiply top and bottom by 15. So you're going to play around with these different equivalent ratios, and let's do an example with this right here. All right. So example number 1: determine whether 7/8 and 49/56 are equivalent ratios. Justify your answer. So let's set these up equal to each other, and we're going to test by that greatest common factor method whether they are the same in value. If we can find that same common factor for the numerator and denominator, right? So if I look close enough, what times 7 and will give me 49, and what times 8 will give me 56. That's the same number. Right? If I look closer enough, I can see that 7 times 7 is going to give me 49. And also, if I use that same number times 7 on the denominator, it's going to give me 56. So since I have the same in the numerator and denominator, I would say yes. Okay, yes, they are equivalent. Okay. So let me show you what that looks like. And right. You also could go backwards and divide by 7. That's another way to check that as well. Right? So you would say this is expressed in this simplest form. Alright. But what happens if, let's say you have two fractions, and let's look at this first, okay? You have two fractions, and it's like really hard to find that common multiple, right? That common factor between the numerator and the denominator. If you have decimals. We can use a different technique called cross multiplication. Right? And what that means is that if you have a fraction a over b equals c over d, you can actually write it where you multiply a times d and c times b, like a little shortcut. Oh, sorry, that's kind of ugly. Right? To get this value. And then you can test whether they multiply together, and if they get the same value on both sides, that means that yes, they are equivalent, meaning they are the same. Equivalent ratios, just a heads up, means the same thing as a proportion. They're the same meaning. Alright, so let's look back at this one right here. Okay, are these going to form proportion? Let's look at this example. So let's set it up equal to each other and test whether that's true. 5 over 2. All right, these are going to cross multiply, right? Kind of like an x. And then, so you're going to write it like this. 2 times 0.25 equals 1.6 times 1.25. So that's how I set that up. Now, all I do is just simplify. Simplify each side. If I have 2.25 cents, I'm going to get 50 cents. And then on the other side, I will get 0.75. Right? And are these equal to each other? No, they are not equal, right? So therefore, I can say that these are not proportions, meaning they are not equivalent ratios. So that's a way to test it when you have decimal numbers. The number is hard to find a factor. So erase that. Let's see a little better. So that's that, and then not equal. And here's an example of those that do form a proportion, right? You kind of do cross multiplication. So 20 times 2, and then 2.5 times 16. And when they equal the same, you would say, yes, they do form a proportion. Right? So now I want you to try some example problems. Checking the progress. You can use the greatest common factor method or the cross multiplication. Think about whether is easiest for you. Go for it.